Hello everyone. Today I am going to take the subject of a circuits theory and the topic is KCL, Kirchhoff's current law, and we will continue the one numerical and we will see how we can simplify the numerical on the basis of the Kirchhoff's current law. So what is the numerical? Find the voltages at nodes 1 and 2 as shown in figure. If you observe this circuitry, you will be able to find the two currents are placed here, that is the 1 ampere and the 2 ampere. Circuitry is given. The nodes are also given, that is nothing but node 1 and node 2. In many cases, node will not be mentioned or drawn. So you need to take as per your circuitry, you just mention the nodes. Okay. So if you observe, the current is there, two currents are there. First is the 1 ampere, second is the 2 ampere, and the resistors are there. 1 ohm, 2 ohm, 2 ohm and the 1 ohm. Here we are interested to calculate the voltages. Okay, so be focused in the current Kirchhoff's current law. We are interested to find out the number of voltages, okay, or the potentials. So what are the steps to simplify this numerical? So all of you go through these steps, okay, just like you were in the previous I have explained about the KVL. The steps are assign. First of all, assign the nodes. How many nodes are there? Number of nodes are there. Okay, so that assign the nodes. Second will be the node position. Where is my exactly the position of a node? Whether if I am having the two nodes, the node 1 and the node 2, you need to decide the position. Third, just apply the KCL. That is nothing but Kirchhoff's current law. That is in the form of your, you can say, write the equation. That is I is equals to V by R form. Okay. And the fourth is nothing but number of voltage you need to find out, simplify the equation, and finally just calculate the unknown voltages. Okay. If you compare these steps in the KCL, so here will be the number of loops, here will be the direction of the current, here will be the KVL, and here will be the number of currents you are interested to find out, equation and unknown currents. Okay. So this will be the comparison between the KVL and the KCL. Now start here. So how you can start? Just note down here, assigning the nodes. So node 1, node 2 is the first is over. Okay, you may give the name here the V1. Second is nothing but your the voltage V2. So in this way we need to calculate V1 and the V2. Okay, so start here by applying what we are doing in this step number 1. Applying KCL at node 1. That is nothing but at this position 1, at this position, this is the 2. So by applying the KCL at node 1, so at present we will apply here. How we can apply? We know very well. We need to simplify like your the I is equals to V by R form. Just like in the KVL, V minus IR is equals to 0. So we need to write the equation in this way. Okay, or you may say in many of the textbook they are referring as V minus I minus this V by R will come here, and that will be equals to 0. In this way also you can write the equation. Now come to this point. Just observe this circuitry, observe this node. Okay, so I is equals to V by R. What is my I? So I will write here I as it is at present. And what is my V? That is nothing but my V1 divided by, at this particular node my R is nothing but the 2 ohm plus. Secondly, at this position this resistor will affect and this resistor will affect. So at present I am at V1. So here V1 minus V2 divided by which resistor? That is nothing but the 2. Okay. So in the second equation here will be my I is nothing but the current I 1 ampere. So here will be V1 will be as it is divided by 2, V1 minus V2 divided by 2. If you do the LCM and all, so you will get as 2 is equals to 2V1 minus V2. So this will be my equation number 1. But in many places the student get confused why we are not getting this V1 divided by 1, because if here is the voltage in many of the numerical, here will be the voltage. If here is the voltage and this potential will be larger, at that time this potential minus of this potential divided by this R will there. Please note down here what I am saying. If potential is here or the voltage is here, that time you need to consider here the voltage. If larger than this minus this one, if lower then this minus of this one divided by R. Okay, so here directly I am taking just because my I will be equals to V by R itself. If you are going to substitute here the I, V by R, so what is my V? That is nothing but V1, and what is my R? That is nothing but 1. Ultimately the indication will be the I is nothing but 1 ampere. So now just second, by applying the KCL at node 2. So what will happen here? V minus I, I is equals to V by R, or you may say I minus V by R is equals to 0. Now substitute here. I am at this position, at this particular position. So what will happen? So this current, okay. So this current is nothing but, right now I am writing as it is this current. So V2 divided by my 1. V2 divided by 1. Now I am at this position. So V2 minus of V1. V2 minus V1 divided by which resistor? That is nothing but the 2. Here what is 2 ampere? So here will be 2. 2 is equals to V2 divided by 1. Again V2 minus V1 divided by 2. So you will get as LCM here the 2. And here will be the 3V2 minus KV1. So finally you will get as, if you are going to substitute, so you will get, even you may note on here like if you want to take this V1 as a positive, or otherwise V1 will be as it is. Okay, so here 2 will be the 4. Okay, so here will be, so finally you will get as minus V1 plus 3V2 is equals to 4 will be my equation number 2. Okay, so ultimately just note down these two equations. So what will happen? See what will happen. Step number 3, equate the equations. By equating the equations, okay, so what will happen? The equating, by equating the equation, what will happen? Note down the two equation at the one by one. So here will be my 2V1 minus V2 is equals to 2. Second is a V1 plus 3V2 is equals to 4. Okay, so what is the one method is nothing but the Cramer's rule, or with the help of the matrix you may simplify. Other method is nothing but just cross multiply with any one of the number and cut it. So what we will do, note on one sentence here, that is nothing but by multiplying 2 to the equation number 2. This is my equation number 2. Okay, just note on here, multiplying by 2 to equation number 2. So what will happen here? The equation will become as 2V1 minus V2 will be as it is. Here will be minus 2V1 plus 2. If I am going to multiply with 2, this will be the 6V2 is equals to 8. So if you are going to cut, so here will be cut, you will get finally you will get as the answer will be, after getting this one, you will get the final answer. V1 is equals to 2 volt and the V2 is equals to 2 volt. Just simplify that above equation, you will get as finally V1 is equals to 2 volt and V2 is equals to 2 volt.